Welcome back. Today we're going to go over similarity and scale drawings. So with this one, we're going to start out with three different vocab words that kind of mean similar things. The very first one is similar figures. Now similar figures, they're figures that they have the same shape, but they're not the same size. And then the next one we have here is corresponding angles. They have to be equal, and the corresponding sides, they'll be proportional. What that basically means is we take a shape, and that shape has to be the same shape, but it might be bigger or smaller, which means all of the angles in that shape are going to be the exact same, but the side lengths will be bigger or smaller. So, point in case, number one here, it says we have to take these two shapes and we want to label the corresponding angles. That means label the angles that are going to be the exact same on both of these shapes, because we have here this pentagon. It has been increased, and now we have a new pentagon that's supposedly the same pentagon but larger, and so we want to find out what angles match up. So we go ahead and start out. If I start with angle E here, you'll notice that the pentagon is facing up. So if I look at this one, it looks like it's been rotated. But if I were to find the point, it looks like R is that exact same point, so I would say that corresponds to angle R. If I were to go on to the next angle, angle F, what would that correspond to? Now most often people will look at this and say that it's going to be V. But if I were to rotate this all the way around so that way R was up here, that means this S would rotate all the way around and be right here, which would be in the exact same position as that F there. So I know that it corresponds with angle F. And then we just work our way around. So we would have angle G, that is going to correspond with angle T. Angle H is going to correspond with angle U. And last but not least, angle I is going to correspond with angle V. Now that we've worked on that with the angles, we can go on to number 2 and look on how we would do that with the sides. So if I look at number 2, it says a parallelogram JKLM is similar to the parallelogram WXYZ. We need to determine which line segments correspond to one another. So I look at this one and I can see, hey, they're the same shape and they're in the same direction. So I'm going to go ahead and start my first one here. And I'm going to look and notice that if I take this line segment JK, and that's why we have this little dash above it, that means line segment. So the line segment JK, right there, which one matches the line segment JK on this parallelogram? If we look at it, it's on the left side, and these are not flipped or rotated, so it would have to be WX that match that. So I would go ahead and take those two values, and I would say the line segment JK and the line segment WX. Those are what correspond to one another. Then I move on and I go to the next line segment. We're going to say the line segment KL. That one is going to correlate with XY. Now the thing about this is we keep the order the same. I'm going from K to L. That means I'm going to go from X to Y. So I have to take that information and write it out and say, hey, that line segment is going to be there. I can then erase those circles and look at the next one. The next one in line would be LM, so I have line segment LM. That corresponds with the line segment YZ. And so I go ahead and do that, and I write it out. So I'd say the line segment LM and line segment YZ, which last but not least leaves us with MJ line segment and the ZW line segment that correspond with one another. And again, if we go back to what it means, if they correspond with one another, that means that those are the sides that we're comparing. And if you look up here again, it says those corresponding sides, they're not equal, but they're proportional. So if this one is, say, 5 feet and it shrinks down, well, all of the rest will shrink at the same rate, so they are proportional. Okay, next question. Before we can go on to the next one, we have our second vocab word. We have a scale factor. Now, a scale factor is like the one that we just barely went over with similar figures. So scale factors, we go through and say that we have a ratio, and a ratio is just a fraction, and it corresponds from the sides of the figure. So we take the new number and we divide it by the original to get a scale factor. And if we divide it out, any scale factor that is greater than 1, means that there is an increase in size. Any scale factor that is less than 1 means that the size decreases. So if we have a scale factor of 2, 3, 4, 5, 6, or 1.1, those would all be an increase in size, whereas something less than 1 would be like 0.7, 0.4, 0.3, 0.1. Those would all be a decrease in size. Alright, so for number 3, we would take this information and notice that the photo is being enlarged. That means it's getting bigger, and it's going to form a 16 by 20. Right now, we have this 4 by 3 or 4 by 5, and its scale factor, we want to know what is the scale factor that made this go from this size of picture to a 16 by 20. So I start out, and I take my information, and I notice that this number 16 and that number 20 are my new numbers, and this number 4 and that number 5 are my original numbers. So I would say that this one is going to be 16 divided by 4, because 16 corresponds with 4. And when I do 16 divided by 4, I'm going to get 4. So that means my scale factor could be 4, but before I can find out that, I have to determine if the scale factor is the same. So I take the next number, 20, that's the new number, and I divide it by the original, which is 5. And 20 divided by 5 does give us 4, so I know that the scale factor is 4 or 400%. So that picture is going to be 400% larger than the original picture. Next question. We take this map, and it says it's going to be reduced to be pocket-sized, so we want to find out the scale factor of the reduction of this map. So this map is 20 by 14, and we would see what size of scale decrease was that to make it so it could fit in your pocket. So I start out with my new numbers, which in this case I have 6 and 3.5 as my new numbers, and that means 24 and 14 are my old numbers, and I do new divided by old, or new divided by original, to get my scale factor. So I take 6 and divide it by 24, because those are the corresponding sides. We can look at the map, it's on the same side as that as on the bigger one. And when I divide it out, I'm going to get a decimal, or the fraction 1/4. I then have to test it with the next one to make sure that it stays the same. So that's 3.5 divided by 14. When you type that in your calculator, you'll find that 3.5 divided by 14 is 1/4. So that means that our scale factor is 1/4 or 25%. So this image is 25% the original size. Last definition, we have scale drawings. A scale drawing is a 2- or 3-dimensional object that can be represented in a scale drawing or a scale model. Some examples of scale drawings or scale models would be a map, a photograph, shadows of an object, blueprints, or if we were to go on to some modern technology, we'd have 3D modeling, where you'd have stuff for a 3D printer, or even CNC machines that would work off of scale drawings to where you're designing it on a computer and trying to make it be as close to lifelike as possible. Okay, number 5. We have to take this information, and it says we want to enlarge or reduce the triangle. So I want to make this triangle either bigger or smaller based on the scale factors. So up here we have the side lengths, scale factor equals 3, we don't know the scale factor, and scale factor equals 1.5. And then these side lengths, AB, BC, CA, those are all these side lengths of this triangle. So currently I just start out by saying, what's the side length of AB? Well, AB has a side length of 5. So that means if I take it and have a scale factor of 3, I'm making it 3 times larger. That means I would go ahead and multiply 5 times 3 and get 15. Then I get the line segment BC, and I say that's 13, so then I would take the scale factor and multiply 13 by the scale factor to get 39. And then last but not least, CA, so I go from C to A, that's 12 long, and that would be 12 times my scale factor of 3, so 12 times 3, and I would get 36 centimeters. To go backwards, now if I use these ones to see what I have, to get this answer, all I would do is I would take 15, and the side that it corresponds to, and I would divide by the original side. So that would be 15 divided by 5. And if I divide 15 by 5, I get 3. If I do 39 divided by 13, I get 3. If I do 36 divided by 12, I get 3. So now I come over to this one. I have no idea what it is, but all I do is I take this number here and I divide it by its corresponding side. So in this line segment AB, I would take 3.75 and divide it by 5. So I do that. 3.75 divided by 5, and that gives me 3/4, or 0.75. That means my scale factor has to be 3/4. I then take my scale factor and I multiply it by the side length BC to get this missing value. So if I multiply that, I'm going to get 3/4 times 13, and that equals 9.75 centimeters. And then last but not least, we just repeat to get this one here, the same steps that we did with the first one. So I take my scale factor, 1.5, and I multiply each side length by 1.5. So that would be 5 times 1.5 is 7.5 centimeters. 13 times 1.5 is 19.5 centimeters. And 12 times 1.5 is 18 centimeters. Okay, last part. Here we have 4 questions, and we need to make sure that we understand how to use the scale factor to figure out some of these pieces. Now I'll go through this fairly quick. You might want to pause it so that way you can go through it yourself and try to figure it out. But on number 6, I go ahead and take this, and I'm going to redraw the image, and I'm going to go ahead and make them all primes, so it's its first move. And I want to know the new side lengths. Well, I just take my scale factor and multiply each side by my scale factor to get my new length. So I would take this and say I have 15 times 2.5, and that would give me 37.5 centimeters. I would take 8 times 2.5, and that would give me 20 centimeters. And then I would take 17 times 2.5, and I would get 42.5 centimeters. For number 7, I noticed that this shape here, A, B, C, D, this one's been rotated on its side, so that's not AB up top there, so I have to remember that this is the side length that I'm comparing in my rectangles. And so to find the scale factor, I take the new number and divide it by the old number, which in this case I can tell that these are the new numbers because they're all A prime, B prime, C prime. It tells me it's been moved first, just like we did over here. To go from the new number back to the original, I have to find which sides correlate with one another or correspond with one another. So I take my new divided by the original, or new divided by old, and I see line segment AB, that would be the old or the original. That corresponds with AB prime right here. So A prime, B prime. I then just divide those two numbers, and I would find out if it's proportional, or not if it's proportional, but I would find out what the scale factor is. So I do that. I divide it and I find out 3. So I could say the scale factor is 3, but I have to test this other number to make sure that that still says 3 to make sure that they are to scale. So if I divide 18.6 divided by 6.2, if I get 3, then that means the scale factor is 3. Number 8 and number 9, same type of thing. Now I could go through and figure out what the scale factor is, and then I could make it so that way I could find x. I prefer to just set up a proportion because it's the same type of thing we've been doing. And so I want to know the proportion here. I'm just going to compare one side to one side and the other side to the other side in my proportion. So I set up line equals line, or the fraction equals another part. And so I have 6 divided by 9, and that again follows the new divided by the original or old. And then I'm going to do the same thing. Because I use 6 here on top, I have to use x on top, and I have to put the 15 on bottom. And just like in chapter 4, we would cross multiply 6 times 15 and divide by 9 to get our answer for x. So 6 times 15 divided by 9, and that would give me 10 inches. Okay, last but not least, this one's probably the most easy one to do without doing any tricks, but I'm just going to walk through just like it was before. So I set up my proportion, and in that proportion it says Susie, she walks 1.5 miles, and she looks at the map, and it shows that the scale is 1 centimeter is 0.5 miles. What's the distance between Susie's house and her school? Well, I just take the values there for what was given, and I would say half a mile is 1 centimeter, so 1.5 miles should be something centimeters. I cross multiply and divide, and I'm going to find out that Susie, on that map, it's going to be 3 centimeters. Hope this was helpful for you. Have a great day.